client as well as REST API and ST discovery, LoRa transceiver. So all this will be designed by a client server technology, and then it will be interfaced with the hexapod. So here you could see that this was the project that's been developed, and here you could see that it has six legs with a lidar and a camera, and all the sensors embedded. So all this have been constructed as a project, and as I mentioned that this will be controlled by the client server, electron client server, through which we will be able to monitor the movement of the bot as well as the direction which has to move, as well as the sensors which is being captured when it moves, and the timings and the exact timings and at what time it has been captured. Everything could be monitored on the screen. So this bot movement will be monitored exactly on the screens, and this will be the temperature and all these values measured will be useful for analysis purpose as well as for the rescue operations. So this control dashboard will provide the exact database of the environment where the bot has been moving, and this data will also be used. It can be stored and can be used for future environmental analysis also. So to come to the first part of the topic, that is hexapods. So as I mentioned, this design will be a modular structure, and it uses adaptive gate control, and it also allows to navigate through the challenging terrains, which also includes confined and debris-filled environments. And this hexapod will also use all the sensors and advanced sensors, so that to make the robot capability of to map the surroundings and to detect the survivors and to ensure the safety in hazardous conditions. And also this bot which is being developed will also reduce human risk, where human rescuers cannot move it on harm place, and it will also minimize the risk and overall safety during rescue operations. And again, real-time data transmission, the robust for robust communication will be including the LoRaWAN technology and Wi-Fi technology, and to ensure that there is a proper connectivity in the absence of internet also, to ensure continuous and reliable data exchange and facilitating the informed decision making and effective remote control. And for again, this could be expanded in other aspects, as I mentioned, not only for caves and darker environments or hazardous environments. It could be also suitable for industry inspections as well as infrastructure assessments and scientific research in extreme environments. So this is about the first part of the topic about the hexapod robots, and the second part of the topic connecting to the AI will be explainable AI in 6 degrees of freedom robotic arm. So this is also a project which was developed and using the concept of explainable AI, where the robotic arm was again, as I mentioned, inverse kinematics IK technology was used, and that mathematical equations I have skipped. You can refer any survey paper for getting the knowledge of inverse kinematics, which will be used for designing the robotic arm or any robots. For designing it, the knowledge of inverse kinematics will be required. So this 6 degrees of freedom robotic arm integrated with explainable AI and computer vision. So here both these aspects have been combined so that we could design a robotic arm as suitable for industrial applications. So here the robotic arm is designed to perform tasks as required by humans with precision and transparency. Again, here the concept of webcam will be used for real-time computer vision, enabling the arm to understand and interact with its environmental effectively. So this robotic arm project will also incorporate with web camera, as well as it will also use the concept of XAI to ensure the decisions and actions are interpretable and explainable to users. So whatever the user uh, uh, is giving in terms of actions, it will be communicated between the robot and the user by using the